Today, let's go over a medium question that I just solved by myself. This one is called Reachable Nodes with Restrictions, and I just struggled with it a bit, but I was finally able to solve it after like a month, so pretty happy about that. This one is a BFS question, so essentially you're given a matrix of integers, meaning that each one's a node that is connected to the other. This is undirected, so I think this means that 2 is a parent of 1, 1 is also a parent of 2, and vice versa for each list, so it's not one directional. And then you can simply just see if you can visit it or not, meaning the node's value is not in restricted list. So pretty simple stuff. You can do this using BFS, using a hash map to map the 0th index node to the 1st index node, and then the 1st index node back to the 0th index node. So if you know that, let's create a dictionary to do that. So let's create a list, and then let's iterate over our 2D list. And again, it's not directional, so we can append E1, and then we can also append E0. And what you'll see is you get an undirected graph. So 0 maps to 1, and 1 also maps to 0 right here, vice versa. And now we can simply do a BFS. So we're going to visit each key and then visit its children and look for the children as keys and visit those until we reach all the nodes in the tree. And we want to make sure they're not unrestricted. So it's pretty simple. And we also want to make sure we're not going to get duplicates. So let's call a set called scene. And let's add 0 because it says right here you can always visit node 0. Note that 0 will not be a restricted node. And let's create a queue. Let's also add 0 to that. And then we're going to do a BFS. So while queue is not empty, we're going to pop from the queue. So it's going to give us 0 first. Okay. And then let's call this results. Another set. We're going to add result to result this current node that we just popped, which is 0. And then so we're going to find 0 as the key, and then we're going to iterate the children, and then find each children as the key and iterate through the children's children, which is the neighbors, as long as they're not in the restricted list. And so let's call this restricted as a set, because if we don't do that, we're going to get time limit exceeded. So now we can just say for neighbor in d current, so current is 0, current's neighbors, and then if neighbor is not in scene, then we can append it to the queue because we need to visit it, right? We don't want duplicate. We don't want to visit one forever. And then scene, you always add neighbor because that's the critical check right there to prevent the infinite recursion or infinite loop. And also neighbor is not in R, then we can do that, right? Because if it's in restricted, then we can't visit it. So for example, 4, it's not a valid path, 5 is not a valid path, so 1 is the only valid path here. Then in the end, I think we can just return the length of the result, which is going to be the set that we just had, right? Because you know all the elements are unique. So pretty easy. And as you can see, it passes all test cases, although it's not the most efficient. This is my own solution, and it's very intuitive. I hope you enjoyed this video, and please stay tuned for more content.